Section 5, Interface Abstraction. Till now, we have seen two facets of microservices. Very early sections, we just built it like a science project. One single file and it was able to do everything. Later on, we learned how to make these microservices in a professional way with configuration, with logging, with documentation. Now, we are going to take it one notch higher. And we are going to try and make this into a microservice which is abstracted. Now, your obvious question might be, why do I need it? This is our current state of affairs. We get the user ID from the context, we look up the sweat for that user, and we marshal the response. However, going forward, we may actually have a slightly different situation. Maybe we look up the user ID from the context as usual, but we may want to go to a different service for users, maybe create a different service for user managers. Interestingly, in the next section, in section 6, we'll do exactly this. We also may want to add some authentication. We want to fetch the sweat from the database and then finally send this information. Now, if we have to do all this, we have to ensure that we are not violating any basic constructs. So we're going to put out an abstraction. Now, putting out an abstraction is as easy as it sounds. This is the problem today. Today, when I try to get the information from the database, I'm explicitly using DB. That DB variable, unfortunately, is a global variable set up somewhere, which gives me direct database access. Now, what we are going to change this to instead is dynamically getting which database you want to use. Notice in this particular screen also, there is a completely different way of doing things. For our sake right now, I'm going to go back to the previous slide. Notice that the handler now has a response writer and a HTTP request for which we handle things smoothly. In this particular case, however, we are returning the handler function itself from this particular method, which is taking the input of a set of dependencies. Now, these dependencies could be the database, could be other microservices, which this particular service depends on. That's why dependencies. And now when we are trying to add these dependencies, in this particular case, we are going to list that user sweat from the database. But in the next section, we'll actually see how we are going to use these dependencies, contact the user manager service, get information about the user, verify it, and then return the information. So without further ado, let's see how this is actually done. We have a simple struct called dependencies in the service package, which is going to define everything that this service is dependent on. But the more interesting part is the storer interface. All the access is going to be through this particular interface for the databases. Now, you might wonder, why do I need an interface for database access? Testing. In the next video, we are going to see how we use mocks to actually do all this testing seamlessly without changing any code and actually getting it done faster and better. So let's start slowly and try to get from the main program. So in sweat.manager main program, we now see this additional line coming in here for service dependencies. In our particular case, we are only setting the database because currently it is our only dependency. Let's see what this dependency file looks like. As simple as that. Interestingly, if we have other kind of interfaces, other kind of service dependencies, we just add them here. You may have to add those relevant packages for them, but which is a minor price to pay. Let's also see what changes we made in the database for the storer interface. As you can see, we still have the database global variable called DB. However, we are not going to access it directly. We are going to access it through this particular interface. And this storer interface is listing effectively all the public methods which are going to access whatever this service wants to do. We have our special MongoDB storer, which we are going to create, instantiate, and use to return the storer interface. Now, this is a complete abstraction of trying to return the database handle and any other dependencies from the storer. Now, what is the changes that we made to the code in this? This is, remember, the sweat file. This is our current change that we made to the database. Instead of just having standard methods which are created on the sweat module, we are now going to implement that interface. We are not doing anything different. We are doing everything that we had done before as is, except that whenever we want to access the database, we are accessing it through the interface abstraction. So this minimal change of code actually helps us move in a complete different direction without having any direct database dependencies.